There was a point during the Cold War when the outcome wasn't decided on the battlefield, but in laboratories, in testing facilities, in places far from public view, where engineers, scientists, and strategists were working on something far more powerful than weapons alone. They were building the future, because in a conflict where two superpowers stood on equal ground militarily, superiority would not come from numbers. It would come from technology, from innovation, from the ability to create systems the other side could not match. This is the story of the technology race that defined the Cold War and how it became one of the most decisive advantages the United States ever developed. At the height of the Cold War, the United States and the Soviet Union competed across every domain: land, sea, air, and space. Each side pushing to develop more advanced weapons, faster aircraft, more precise missiles, more effective surveillance systems. Because technology wasn't just a tool, it was a foundation of strategy. Whoever could see further, react faster, and strike more accurately would control the balance. But this competition wasn't always visible. Some of the most important breakthroughs were classified, hidden behind layers of secrecy, developed in isolated facilities, tested far from public attention, because revealing these capabilities too early would reduce their advantage. For the United States, this created a unique approach. Innovation wasn't just encouraged, it was prioritized. Resources were directed toward research, toward experimentation, toward projects that, at first, seemed uncertain, because the goal wasn't just to improve existing systems. It was to create entirely new ones, technologies that could change how warfare was conducted, how intelligence was gathered, how decisions were made. But this approach came with risk, because not every project succeeded, not every idea worked. And in a competition where time mattered, failure carried consequences. The Soviet Union was developing its own capabilities, advancing its own systems, closing gaps wherever possible, which meant the advantage was never guaranteed. It had to be earned, maintained, extended. That was the problem. How do you stay ahead in a race where the other side is always trying to catch up? Because falling behind wasn't just a setback. It could shift the balance entirely. It could create vulnerabilities, open gaps in defense, limit options in a crisis. So the United States had to do more than compete. It had to lead, to push beyond incremental improvements, to develop technologies that would redefine the environment itself. And if you're interested in Cold War stories like this, where the most important victories were achieved through innovation rather than confrontation, consider subscribing, because what the United States would build next would not just match its adversary, it would move beyond it, changing the nature of the competition and the outcome that followed. To move ahead, the United States didn't rely on a single breakthrough. It built momentum across multiple fields at the same time, because true advantage wasn't created by one system. It was created by an ecosystem of innovation. One area where this became immediately clear was in the sky. High above the reach of conventional defenses, American engineers developed aircraft that could operate faster, higher, and more efficiently than anything before them. These weren't just improvements. They were leaps. Aircraft designed not only for combat, but for information. Reconnaissance platforms capable of flying at altitudes where interception became nearly impossible, collecting intelligence with a level of detail that had never been achieved. Because in the Cold War, information was power. Knowing what the adversary was building, where it was located, and how it was being deployed gave the United States a strategic advantage that could not be easily countered. But the race didn't stop in the air. It extended into space, where satellites began to change everything. For the first time, it became possible to observe entire regions from orbit, to monitor missile sites, track movements, verify activity, all without crossing borders, all without direct confrontation. This reduced uncertainty. It replaced assumptions with evidence. And that shift alone altered the balance, because decisions could now be made with greater confidence, greater precision. At the same time, advances in computing began to influence how information was processed. Data that once took time to analyze could now be handled more efficiently, allowing faster reactions. more accurate assessments, better coordination between systems. These developments were not isolated. They were connected, each reinforcing the others, creating a network of capabilities that extended across domains: air, space, sea, and command. But perhaps one of the most important areas of advancement was something less visible: stealth. The idea that an aircraft could operate without being detected, that it could enter defended airspace, complete its mission, and leave without being seen. This wasn't just an improvement in design. It was a change in how warfare could be conducted, because if detection could be avoided, then defense could be bypassed. And if defense could be bypassed, then the entire structure of protection had to be reconsidered. This forced the Soviet Union to react, to adapt, to invest in countermeasures, often without fully understanding what they were facing. Because many of these technologies remain classified, their full capabilities unknown. And that uncertainty created pressure, because reacting to something you cannot fully see is far more difficult than responding to something you understand. This is where the advantage began to grow, not just in capability, but in perception, because the United States was not only developing advanced systems, it was shaping how those systems were interpreted. And if you're interested in Cold War stories like this, where innovation quietly reshaped the balance of power, consider subscribing, because what would happen next was not just about building new technology. It was about proving it, demonstrating that these systems worked in ways the world could not ignore. The true measure of any technology is not in its design, it's in what happens when it is used. Because concepts can be promising, prototypes can be impressive, but only real-world performance proves whether an advantage is real. And during the Cold War, there were moments when that proof became undeniable, moments where technology moved from theory to dominance. One of the most important of these moments came in the skies, when advanced American aircraft began to demonstrate what superiority looked like in practice: faster response times, more precise targeting, greater situational awareness, all working together in a way that transformed combat itself. It wasn't just about individual performance. It was about integration, systems communicating, pilots receiving better information, decisions made faster, executed with greater accuracy, because the advantage wasn't just in the aircraft, it was in the system behind it. At the same time, intelligence capabilities reached a level that changed how operations were conducted. Satellite imagery provided continuous updates. Reconnaissance missions filled in gaps. Electronic surveillance revealed patterns. Together, they created a clearer picture than ever before. And with that clarity came confidence, the ability to act based on knowledge rather than assumption. But these advantages were not always visible. In many cases, they were demonstrated quietly, in operations that remained classified, in missions that were never publicly acknowledged, because revealing the full extent of these capabilities would reduce their effectiveness. Still, even without full visibility, the results became apparent. The Soviet Union began to face increasing pressure, not just from military capabilities, but from the pace of innovation itself, because keeping up required resources, time, coordination, and in a system that was more centralized, less flexible, that process became more difficult. Meanwhile, the United States continued to evolve, building on each success, refining systems, expanding capabilities, because innovation was not a single achievement. It was continuous, relentless, and over time, that consistency created separation, a gap that was not always obvious, but increasingly difficult to close. There were moments when this gap became clear, when American systems operated with a level of precision and effectiveness that could not be easily matched. Moments where the outcome was not uncertain, because the advantage had already been established before the operation even began. And that changed the nature of the competition, because now the race was no longer equal. One side was advancing faster, adapting more quickly, integrating more effectively. And that momentum mattered, because in a long-term competition, momentum becomes decisive. And if you're interested in Cold War stories like this, where the outcome was shaped long before any confrontation. Consider subscribing, because what this growing advantage would lead to was not a single moment of victory, but something more gradual, more complex, and ultimately more decisive than any single event. In the end, there was no single moment when the race was declared over, no final test, no decisive confrontation that made it official, because the outcome of the technology race wasn't defined by one event. It was defined by accumulation, by years of continuous innovation, of systems improving faster on one side than the other, of ideas turning into capabilities, and capabilities turning into advantages. For the United States, that advantage became increasingly clear, not just in individual technologies, but in how they work together. Aircraft supported by advanced intelligence, missile systems guided by more accurate data, command structures operating with greater speed and coordination, all forming a network that could adapt, respond, and evolve. At the same time, the cost of keeping up began to rise, because matching these capabilities required more than replication. It required the same level of flexibility, the same capacity for innovation, the same ability to integrate across multiple domains. And that proved difficult, because the race wasn't just about building technology. It was about sustaining it, improving it, expanding it continuously. And over time, that pressure became a factor, not always visible, but always present. Because in a long-term competition, the side that adapts faster shapes the outcome. The Cold War was often seen through the lens of military power, of weapons, of numbers. But beneath that surface, technology played a different role. It influenced decisions. It reduced uncertainty. It created options that did not exist before. And in doing so, it shifted the balance. Quietly, consistently, without the need for direct confrontation. That is a legacy of the technology race. Not a victory announced in a single moment, but an advantage built over time. Through innovation, through persistence, through the willingness to push beyond what was already known. Because in the Cold War, the most important breakthroughs were not always the most visible ones. They were the ones that changed how the game was played. And once that change happened, the outcome followed. For more stories like this, make sure to like the video and subscribe to the channel, because some of the most decisive victories in history were not won on the battlefield, but in the ideas, systems, and technologies that shaped everything that came after.